Hello friends, today I'm going to solve LeetCode problem number 2389, longest subsequence with limited sum. So what are we given? We are given two arrays, nums and queries, and we need to return an answer array where the value of answer at index I is the maximum size of subsequence that we can form from nums array, such that sum of each elements in that subsequence is equal to or less than the value at index I in queries array. So let me just explain you what does that mean. So we have this nums array and then queries array, right? These two array, the queries array is of size m, nums array is of size n, and we need to return an answer array which is also of size m. So what's the size of the queries array? It's equals to 3, right? So we need to return an answer array of size 3, and the value at the index I should be equals to the maximum size of the subsequence that we can form from this nums array, right? Subsequence. So what is subsequence? Means that taking all or some of the elements from this array, and suppose 4 is a subsequence of 5, taking only one element also form a subsequence. Taking two elements would also form a subsequence, like 4 and 5, or 4 and 2, and so on. And taking three elements like 5, 2, 1 would also form an element. So it doesn't need to be in an order, because we have not been said that. Let's see what subsequence actually means. Subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So basically subsequence means we need to form one or more of these, and we do not actually change the order. But the order doesn't really matter here, because what we need to find is we need to find the subsequence where the sum is less than equals to 3, sum of all the elements in that subsequence less than equals to the value at this index would be, and the value at this index. So basically that is what we need to find. Now let's see what would be the value be at index 0. So for index 0, the value at index 0 at queries array is equals to 3, which means that the sum of elements in our subsequence must be less than or equals to 3. Now which elements result in the value less than and equals to 3? Of course, 2 and 1, adding these two elements result in less than equals to 3, right? Which means the maximum size would only be equals to 2. Maximum, we need a maximum. 2 is also a subsequence. Only 2 will also form a subsequence less than 3, but that won't be a maximum size because the size would be 1. So we need the maximum. So that is why our answer would be 2 here. What about 10? To find the 10, the subsequence would be 4, 2 and 1, right? That would result in the size of 3. And for 21, we can take all the elements, then the value would be equals to 4 for this index. Now we know that what we need to find. Let's see how can we achieve that. So first of all, what we need to do is, since we have been asked to find the maximum size, which means that we need to collect the subsequence would have elements which have the values, the lesser the value, the more item we can collect, right? For example, I have a nums array of these with these elements. Now if I create a subsequence of 1 and 2, the value would be the maximum size would be 2 for index 0. What about if I take this value? Well, it would only be of size 1, right? The size is only 1, so this is not the maximum size. We need the maximum. So we can achieve maximum if we take start from the least value and then keep on moving like in an ascending order. So that is what we will be doing. We will first of all sort our nums array into ascending order, and then since we need the sum, we need to find the sum, so we will sort it in an ascending order. So we have now the nums array in a sorted form, and now we will find the prefix sum of these arrays. So the prefix sum would result in something like this, where this value 3 is equals to the sum of these two elements, and then the next value will be equals to 7, which is equals to the sum of this element plus this element. So basically the next value would be 7 plus 5, which is equals to 12. So this will be our prefix sum. Now to find the maximum size, we will look into the array, and then we will find the value which is less than equals to the value at this index, and then we will return the index. The index will represent the number of elements. So since this is at index 1, this would represent that it consists of 2 elements. So we'll return index I plus 1. So that would be equals to 1 plus 1 equals to 2. That would be our answer here. Now in case of 10, we know that 10 is less than 7, greater than 7 and less than 12, right? We do not want any value, we do not want it to be greater than 10. So we take this index here, and this is as index 2, and then we add a 1, so the value would be equals to 3. And similarly for 21, 12 is less than equals to 21, and there is no other elements here, so that is the last one. So we return the index 3 added by 1, which is equals to 4 as our final result. So now we know how to now we know the algorithm. Let's try to code our solution in JavaScript. So n equals to nums.length, and then what do we need? We need to sort this nums array, right? We need to sort it, and then we need the prefix sum. So let me first sort nums in ascending order. Now we need the prefix sum, so let prefix sum equals to a new array, and then each element, for each element of nums array, let me just push the first element. Now let I equals to 0, I is less than, and I plus plus. The next element would be sum of I, not sum, nums I plus prefix sum or at index I minus 1, right? Because here, to find the value of 7, what did we do? We add the value at the same index in our sorted nums array and the previous one in our prefix. So that's what we are doing. We are taking the previous value in the prefix sum and the value at the same index in nums array, that is a sorted one. Now once we have our prefix sum, now to find these elements based on the value of the queries, find the index, we will be using binary search. So let's define our binary search function. We'll pass 3 arguments, left, right, and the target value. Now while left is less than right, what do? Is we find our middle value, which is the I'll take the ceiling value here, and if prefix sum, the value at prefix sum is less than the value at target, which means that the value our index lies to the right hand side, right? So what I'm gonna do is left equals to m, else less than equals to else, right equals to m minus 1. Now what I'm going to do is for each of the values in queries element, queries array, we need to find for each of those, right, index for each of those, that is so what I'm going to do is answer equals to, okay, we also need the answer array to store our answer. Array, okay, answer equals to binary search 0 and minus 1, and the value of target would be the value q, and push it to our answer array, push the answer, and then finally return our answer array. Now let's try to run our code and see everything works fine or not. Okay, so we start from index 1 because we have already pushed our first element. What is again wrong? Prism is not a function. I need to push it. Yes, so we also need one base case here to check if the first element at queries I is less than the first element at our nums yeah, so what I'm gonna do here is answer equals to 0, and then if the value q is greater than nums, not nums but presum at 0th index, only then we are going to perform our binary search, else we are not going to perform our binary search, because the first index in our presum would be less than this. That would result in the number of size equals to 0. So yes, cool, let's submit it. Greater than equals to. So the time complexity for this solution, since we are sorting it, so this would take off big O of n log n, and then what are we doing else is this is of O of n, and then we are performing a binary search on each of the elements in the queries array, right? So that would be m for each element. This is queries array which is of length m, and we are performing binary search on each of those, right? And binary search is log of the size of the array, so that would be m times log of m plus n times log of n, and the space complexity is O of n because we are using presum to store the index sum, right, of nums array and also the answer array. So yeah, hope it was helpful.